friends, so let's talk about the F statistics and p-values in two-way ANOVA. So let's recall the ABC, the producer of eye drops to relieve minor eye irritations. The researchers have noticed that the droppers deliver differing amounts of liquid. To ensure customers obtain a consistent amount of eye drop, the researchers are investigating how many millimeters of liquid the current and modified eyedropper will dispense of both the product A and product B. In an earlier lesson, we defined our null and alternative hypothesis for a two-way ANOVA for this study. Now we are ready to examine the F statistics and p-values in the ANOVA table, as we did earlier for one-way ANOVA tests. So first, let's look at the hypothesis to test whether an interaction is present. The F statistics is the ratio of the between to within group variation. If the between group variation is more relative to the within group variation, there is little evidence that the population means differ. On the other hand, if the between group variation is large relative to the within group variation, evidence suggests that the population means are not the same. The F statistic suggests that a difference is present. So, should we reject the null hypothesis that the mean response among the levels of dropper type does not depend on the product type? We use the p-value. To answer this question. The p-value is the probability of obtaining an F statistic at least as extreme as the actual calculated value given the null hypothesis is true. If the p-value is greater than alpha, we fail to reject the null hypothesis. If the p-value is less than or equal to alpha, we reject the null hypothesis. In a two-way ANOVA, we first need to test whether a significant interaction effect is present. For ABC study, we'll use the most common value of alpha for ANOVA, 0.05. The p-value of their hypothesis test is 0.028. So should we reject or fail to reject the null hypothesis? We see the p-value is less than alpha, so the results are statistically significant. From these results, we know a significant interaction is present, but how can we better understand how the factors affect the response? So let's return to the interaction plot. Here we can see the product type beef will have a consistent dispensing amount of for both the current and modified eyedropper. So ABC decides to switch to the product B for both dropper types. Because the interaction is significant, it does not make sense to look at the main effect for each factor individually. So let's review. We learned how to use the p-value to interpret the results of two-way ANOVA. If the p-value is greater than alpha, we fail to reject the null hypothesis. If the p-value is less than or equal to alpha, we reject the null hypothesis. Thank you for your listening. In the next lessons, we'll talk about the assumptions and residual plots.